Hey guys, welcome to the Market is Open. Today we're going to do the proof for the growing annuity formula. We previously did the proof for a growing perpetuity formula. This formula is quite similar, so I'm going to introduce the variables. CF is the cash flow, so that is what you get in the period. For instance, let's say your earnings next year were $100, then that would be the cash flow. PV is the present value. That is the present value of all those cash flows summed together. So what would be the present value of $100 if you receive that payment 1 year from now, 2 years from now, 3 years from now, 4 years from now? G is what that cash flow is growing at. For instance, if it was growing at 2% a year, the first year would be worth $100, and then the next year would be $102. R is the discount rate. Discount rate, the easiest way to think about it is, let's say the discount rate was inflation. If inflation is 2% and you have $100, what is $100 worth next year? So $100 next year is worth $100 divided by 1.02, or it would take you $100 times 1.02 to purchase the equivalent amount of money. So it will basically take you $102 to purchase next year what it costs $100 today. And the last variable is time, which is n. So here's our original equation. So basically what this is saying is cash flow divided by 1 plus r plus the cash flow in the next period times 1 plus g to the power of 1. So again, if that was 100 and g was 2%, that would be 102 divided by 1 plus r squared. So what is inflation, or the discount rate? So that is what you want to get per year. And that would be, let's say, again, 2%. So 1 plus 0.02 to the power of 2. And then this ... is just showing that we're going all the way to the last period. We don't know what n is, but let's say n is 10. So this would be ... It's representing a bunch of times until we reach that point in time where we get to n minus 1 divided by n. So what this is symbolizing is just that I'm not writing out all the numbers to the power of 2 divided by to the power of 3. I'm going to skip that and just write to the power of n minus 1 divided by n. It saves a lot of writing because you don't want to write everything out in the equation. For instance, what happens if it was to the power of 100 time periods? Then you'd be writing out for an extremely long period of time. So that is the first part. This is the first equation, and this is what the present value of a growing annuity would be. As mentioned, you could either do it all by hand, or you can use the formula, and right now we're going to derive the proof on how you get that formula. So this is the first equation. The second equation that I'm going to use is going to be to multiply this first equation divided by 1 plus r times 1 plus g. So right now this first equation is this, but we've noticed that there's a common factor of 1 plus g divided by 1 plus r, and to eliminate this some of these factors and to reduce the equation, we're going to multiply times 1 plus r divided by 1 plus g. Obviously, you could play around and try to figure out what is the common factor, but I'm just going to tell you in this case because we're doing the proof. So in normal mathematics, you wouldn't know that this was the common factor. So this is the skill of the mathematician, is to figure it out. But the person using the formula should understand the proof, because if you don't understand the proof, then you're kind of just blindly using a formula, and then when things change a little bit, you sometimes don't understand it. So it's important to understand the proof, but understand here that I'm giving you the common factor, which is going to help you solve the formula. Okay, so this is the second equation set up. So here is the first equation, which is in the brackets, and then we're multiplying by 1 plus r divided by 1 plus g, which means that we're going to multiply each thing inside the brackets by this term. And I'll show you on the next line what it looks like. So one thing important to note is that if you multiply one side by 1 plus r divided by 1 plus g, you have to multiply both sides of the equation. So right now you can see the equation set up where we've multiplied both sides by 1 plus r divided by 1 plus g. And now you can see what's going to cancel. So I'm going to grab a pencil and just see, look at this, 1 plus r is at the bottom, and then 1 plus r at the top, so that cancels. It's because we're doing multiplication, and these two numbers would be the same. So there's a multiplication and there's a division, so we're going to drop that off. then you can see that there's a 1 plus g over here and a 1 plus g over here. This one is 1 plus r to the 2, and there's 1 plus r to the 1. So 1 plus r is going to drop off. So this is going to become to the 1. So that's important to remember. And then there's going to be a lot more things dropping out all the way to n. So just recognize that I'm not going to be crossing out everything, but there are more things crossing out all the way to the n. Then we're seeing this 1 plus r crosses out here. And then this is going to be 1 plus r to the n minus 1 because one of the final n crossed out, but what didn't cross out, there was n minus 1 right before that. And then this 1 plus g crosses out, and this is going to become to the n minus 2. So one of these g's crosses out. So all of that crosses out. Okay, so after we've crossed out, we get this, the left side of the equation we're not going to touch for a bit, but you can see that we get cf divided by 1 plus g plus cf divided by 1 plus r. Then there's other things that are crossing out, or other things that as we go on that we're not showing. But the next one would be, if we were to show it, cf times 1 plus g to the power of 1 divided by 1 plus r squared. So similar to what you're seeing here, but it's not shown because there's no reason to write it all out. And then the last number that we have is cf times 1 plus g to the n minus 2 because we crossed out 1 over here because it canceled. So the one thing before n minus 1 is n minus 2, which is why it became n minus 2, and 1 plus r to the n minus 1 because the number before n, so if the last number was 1,000, the one number before it would be n minus 1, or 999. So that's why it becomes that. So this is equation 2, and then we're going to move to equation 3. So equation 3 is going to be the first equation, equation 1, minus equation 2. So we're going to take this equation and then minus this equation. Okay, so now you can see the equation PV, which is equation 1. I'm just going to point to it. And then minus equation 2. So this whole part, PV times 1 plus r times 1 plus g, is equation 2. So let's just point to it. This first part of the equation is equation 1. So this part in these brackets, and then this part in this brackets is equation 2. So we're minusing equation 2 from equation 1. And if you notice, look what's going to cancel. So all these numbers inside these brackets becomes negative, right? Because we have a negative in front, so everything here is multiplied by a negative. So this is negative cf divided by 1 plus g, and then this is negative cf divided by 1 plus r. But look at these numbers that cancel. So this is going to cancel with this. And then all these numbers, the next number here that I'm not showing is cf divided by 1 plus g to the power 1 divided by 1 plus r squared. So that's going to cancel with this. And then notice that this number right before this number is going to be n minus 2 divided by n minus 1, right? But it's not shown, but this number right before this is n minus 2. So that there's a number here before that that's canceling, so this number is going to cancel. So what we're left with is this number, cf divided by 1 plus g, and we're left with this number here. So I'm going to rewrite the equation showing that. Okay, so when we reduce all of that, we still have the left side of the equation, and then we have cf times 1 plus g to the n minus 1 divided by 1 plus r, and then minus cf times 1 plus g. So what we're going to do here is we're going to multiply both sides by 1 plus g, because it's going to look like a lot of things are going to cancel. So we'll see what that looks like when that happens. Okay, so hopefully you can see now that this is going to cancel. So this is gone. Then this number is going to become to the n because there's n minus 1 times another 1 plus g. So this number is going to get added. We're just going to leave that for now. Then these two numbers are going to cancel. And then this is going to become PV times 1 plus g. And then this is going to be minus PV times 1 plus r. Okay, so now the equation looks like this. I just removed the multiplication because when you have a parentheses next to it, it's the same thing as meaning multiplication. So just to make it cleaner, so we have PV times 1 plus g minus PV times 1 plus r equals this equation minus CF. I'm now going to divide by -1 on both sides just because in most equations they show the cash flow number as positive. So we're going to divide by -1 on this side, which means that this side is going to change sides. And I'll show you what that looks like. So you can see that everything just switched sides. So now the PV 1 plus R, and then this PV 1 plus G, and then we have the CF minus this number. Now I'm going to multiply this out. So this is going to become PV plus PVR, and this is going to be minus PV minus PVG. So this becomes minus PVG because it's multiplying. This whole thing is negative. But look what we can cancel now. We have this PV and this negative PV, and then we have this PVR minus PVG. So let's take that to the next step. Okay, if you notice this, you may notice that we could factor out a PV from both sides of this, and then we just have R and G. So we're gonna have PV times R. Okay, so the next thing to do would be to divide each side by R minus G. So we're gonna divide this side by R minus G, which would mean we just have PV left on this side. Then we're gonna divide this side. Notice you have to divide both sides because there's a negative sign. So it becomes CF divided by R minus G. And then this side divided by R minus G. Okay, so I'm just going to show this a bit more in detail because no one really ever explained this to me when I was doing math. But see how we have this equation, CF times 1 plus G divided by 1 plus R? This is one thing. And then when we divide by R minus G, this R minus G is its own thing. So we divide by R minus G, and R minus G, dividing by R minus G is the same as dividing by R minus G minus 1. And then the same thing as division as multiplication. So all we have to do is switch this over. So this becomes times 1 divided by R minus G. Okay, so now when you look at this, notice that you have a CF. If we move this over this R minus G, because it's multiplication, it's the same thing. Both sides have a CF divided by R minus G on both sides. So we could take that out of the equation, and this part already canceled out from before, so this is just PV. So we're going to take a CF times R minus G out of each side. So when we take the CF times divided by R minus G, we took it out of this side, but in order to get that number, this number here would have to be 1. Because if we didn't have it, then we wouldn't have anything before the negative. So this 1 represents CF times R divided by R minus G times 1 equals this number right here. And then we're going to minus the other side of the equation, and this CF divided by R minus G is already there. So this side of the equation is just going to be 1 divided by G, 1 plus G to the power of n divided by 1 plus R to the power of n. And there it is. This is the proof for the growing perpetuity formula. This is the final answer right here. Oh, hey guys, so let's just look at an Excel to see if the proof works. So we're going to assume that the cash flow, the first one is 1,000, the growth is 2, the discount rate is 4%, and the time period is 5. So the first cash flow is 1,000, then it's multiplied by 1 plus 2, then it keeps being multiplied by 1 plus 2, and the last cash flow is 1082. The discount rate, the first one is 4%, so we have 1.04, that's 1 plus R. The next one, 1.04 to the power of 2, to the power of 3, to the power of 4, to the power of 5. And then these two numbers divided by gets our present value. So when we add them all up together, we get 4626. Or we could use the formula. So if you're looking at the formula, you have CF divided by R minus G, which is 50,000. That's just the growing perpetuity formula. Then you multiply it by 1 plus G to the power of n, which is 5, divided by 1 plus R to the power of n, which is 1.21. And then you do 1 minus that. So it's 50,000 times 0.09, which then gets this number of 4,626. So you could see that the proof and the formula worked. Please, if you like this video, let us know so we could do more financial education videos. Please smash the like button and subscribe to our channel.